Cosmological constant problem, a possible solution if vacuum energy is photons. The cosmological constant problem is one of the biggest problems in physics. Here's the simplified form. The theoretical calculations of vacuum energy is 120 to the 10th larger than the cosmological constant, which is the amount of the expansion of the universe. They should be the same. Vacuum energy. Vacuum energy is the energy that pops up anywhere in empty space all the time. This happens when virtual particles pop up out of empty space. The virtual particles always come in opposite charges like electrons, positrons, pairs. They then almost always annihilate back into the vacuum energy pool. Cosmological constant. The cosmological constant is the energy that is expanding the universe everywhere from empty space. This is also called dark energy and makes up at least 70% of the universe. Many think that vacuum energy is causing the expansion of the universe, but the numbers don't add up, not even close. Or do they? Before going further, this post is a rough draft of an idea that I suggest could solve this problem. It comes with this disclaimer. Much of this is unproven speculation, though it is mostly built on what we know already. The diagram shows a photon faucet pouring out electron-positron pairs that are expanding the universe. Here's the key to what follows. Vacuum energy pops up as virtual electrons and positrons. The only thing that can make electrons and positrons is photons. Therefore, my model claims vacuum energy is a photon singularity, the faucet. Further, this photon singularity not only started this space-time universe, but it is a singularity of photons that are outside of time and distance, outside space-time. Though clearly we can still measure time and distance of photons with the speed of light, but that dual nature of photons is for a different post. My suggestion is that both vacuum energy calculations and cosmological calculations are correct. There is a massively large vacuum energy pool of virtual particles in a photon energy universe. And there is a much smaller dark energy that is expanding the universe. They are not and should not be the same at all. This, if confirmed, offers many clues. First, why is vacuum energy so large? My suggestion is that vacuum energy is the same singularity of energy that started this universe. This vacuum energy universe has only photons. These photons, like the ones in this universe, are outside of space-time. Many have problems with this. Please read the fine articles online that explain it better than I can. Photons are outside of time and distance, so that suggests that we're here before the universe and that the universe was a subset of that photon singularity. Therefore, the photon singularity universe, or vacuum energy, should contain all energy and should be massive, just like the calculations for vacuum energy say it is. This could also conceivably be a way of measuring the energy in the singularity that started the Big Bang. Photons are the only known way for energy to make mass. Photon energy does this by creating electron-positron pairs. Therefore, a photon singularity of energy can make electron-positron mass. The process is called pair conversion. But remember, all vacuum energy is virtual electron-positron pairs that pop up. Therefore, I suggest this key point. The only way vacuum energy could make virtual electron-positron pairs is if it was a photon singularity. Therefore, vacuum energy, or all the photons in the photon singularity, should be massive. The amount of electron-positron pairs that enter and stay in the universe should be small. Both fit the calculations of vacuum energy and the cosmological constant. Next, why is the cosmological constant so small? Because not all vacuum energy gets into space-time like it did at the Big Bang. There seems to be a barrier in the space-time universe where virtual particles are either too weak, or the temperature of space-time too low, or space has grown too large to allow most of them into the universe. But this barrier was crossed during the Big Bang and for some time after. Now, not so much. My suggestion is that some, but not much, vacuum energy enters. There is enough that crosses the barrier to cause dark energy and expand the universe. That makes up the smaller cosmological constant. The photon singularity makes virtual electron-positron pairs, and a few still enter. Follow-up question. So why is expansion speeding up? My best guess is that though there are less virtual particles coming in, there is more space for them to enter. Then, too, most of the matter building that made stars, etc., is over. But all that's just a guess. Here's an analogy for this post. Imagine a photon faucet. That is the singularity before the Big Bang. This pours not photons, but only electron-positron pairs. This started the universe in space-time when it poured a massive jet of electron-positron pairs. As space quickly expanded and cooled, the amount of pouring in was less and less. Now the faucet is almost turned off. This is all part of my bigger model. Thanks for reading.